Okay, hello everyone, this is Melissa, your math teacher, and wanted to do a few more of the factoring by grouping problems. And let's see, I had posted this one yesterday, but I wanted to redo it because it was such a short video that I wanted to include some other stuff in it. Okay, so this problem, what I had said yesterday in that first part 1 video was that if your leading term is negative in the second grouping when you're factoring by grouping, that you want to pull out the negative. So I'm going to take a look at these two different groupings, and I'm going to pull out the greatest common factor within each grouping. And the reason that I'm doing that is obviously because I've looked at the problem, the directions say factor, and I've looked at the problem and there's no greatest common factor in the entire problem. And then if I use my, that's right, my handy dandy factoring flow diagram, and is there a greatest common factor, question mark, there's not. So how many terms are there? There's 4 terms, factor it by grouping. So that's why I'm using this process here. Okay, so in the first grouping, the greatest common factor is a 2 and also an x squared. So if I pull the 2x squared out, and then I'm going to be left with an x in order to get that back, and a plus 6 in order to get that term back, the 12x squared. Okay, remember here that I need to pull out the negative, so pull out the negative, and then the GCF in this second grouping here is actually a 5. So I'm going to pull out a negative 5. And when I do that, I'm going to be left with an x, and notice that my sign needs to change here to a plus 6. The reason for that is if I think about distributing, the negative 5 times the positive 6 would give me a negative 30. Okay, so that's correct in getting that back. And then this is what I fondly refer to as the magic. There was no greatest common factor before, but now there is, and it's an x plus 6. So we're going to factor that out, and I'm going to be left with, to get this whole term back, I'm going to be left with a 2x squared. And then to get this term back, I'm going to be left with a minus 5. Okay, so that's that problem. Somebody had sent me a question off of the homework. I think it's out of, the question was 5.1.35. And I wanted to just do that problem here. The question was to factor x to the 5th times x plus 6, and then plus 9 times the x plus 6. Okay, this problem is actually already partially done for you. If you notice in comparison to this problem up here, this was a factoring by grouping problem, but when I did the grouping, I got down to this position right here, right? Okay, notice how similar this problem is to where this is location, this one's location in the problem right there. This is like a factoring by grouping problem that's already partially done. Basically, the magic is already showing there as an x plus 6. Okay, so that's actually the greatest common factor. And so what I would do here is I would actually pull out the x plus 6, and again, look for what do I need here so that when I multiply this whole x plus 6 as a quantity times whatever I put here, that I get this whole term back. Okay, so if I make it an x to the 5th, obviously when I take this times that, it's going to give me that whole term. And we're used to thinking of distributing, but we don't want to think of that here. We don't want to think of taking the x times this and then the 6 times that separately. We're thinking of taking this as a whole quantity times that would give me this back. And then I would need the plus 9 in order to take this times that and get this whole term back. Okay? All right. Let's do maybe 1 or 2 more of these. Here's another problem. Same directions. We're factoring 6x cubed minus 9x squared plus 4x and then minus 6. Okay, so we are thinking, as always, about our factoring flow diagram. The first question we're going to ask ourselves, is there a greatest common factor? Let's look at the problem. Throughout the entire problem, there actually is not a greatest common factor. There's nothing that they all share in common. Okay, so then we go down and we ask ourselves the question, how many terms are there? And there's 4 terms. Okay, so that means that we're factoring by grouping. So taking these first two, taking the second two, and grouping. In the first grouping, I'm going to pull out a 3 and also an x squared. And then I'm going to be left with a 2x to get this 6x cubed back. And then I'm going to be left with a minus 3 in order to get the 9x squared back. Okay, the second grouping here, what I would pull out is a 2. That's what they share in common for the greatest common factor. And then I'm going to be left with, again, a 2x minus 3 to get those terms back. And what do you notice? It's magic. Here's our greatest common factor now. So we can pull that out. 2x minus 3 comes out as the GCF. And we're left with 3x squared in order to get the first term back. And then plus 2 in order to get the second term back. Okay, I think I can do one more in the time limit. YouTube keeps me to 10 minutes per video, so I have to kind of work within that. Okay, same directions, factor. We're looking at, ooh, can you see that? Okay, there we go. X cubed plus x squared plus x plus 1. And there's a reason I keep going back to this thing, because it's helpful. Is there a greatest common factor? And if we look at the problem, throughout all 4 terms, there isn't a greatest common factor. Okay, so we're going to say no. We go down, ask how many terms are there. There's 4 terms, so we're factoring by grouping. Okay, so within this first grouping, within the second grouping, I'm going to take out the greatest common factor. Within the first grouping, I see that my greatest common factor is an x squared. Okay, I pull that out and I'm left with an x plus 1. In the second grouping, there actually is not a greatest common factor there. So we're going to write it with a 1 on the outside to show that the 1 is basically the greatest common factor. Okay, and there's our magic. The x plus 1 is now greatest common factor for the entire problem. If we pull that out, then we're left with an x squared in order to get this term back, and a plus 1 in order to get that term back. Okay, I'll see you guys in a minute. I'm going to do another video, so